Hi everyone, thanks for being here today. I'm Priyanka Singh from DTU, and today I will be quickly sharing our project idea for ODIN Grant 1 application on developing hybrid green-silver nanoparticles and MOF-based surface to fight antimicrobial resistance and biofilm infections. Antimicrobial resistance is becoming a major global healthcare challenge. As you can see here, AMR is already causing around 1.3 million deaths globally, and this number may increase dramatically by 2050. Why this is happening is also equally important to understand, and this mainly happens due to the ability of bacteria to fight the antibiotics. Bacteria can use multiple different resistance mechanisms. They can destroy antibiotics, they can pump them out, reduce the drug uptake, and most importantly, they can form the protective biofilm layer, which make them even stronger because they allow bacteria to grow together as a community under a protective sheet-like layer. So there is a very strong need to design a smarter antimicrobial system that can fight the bacteria as well as the biofilm through multiple killing mechanisms. And here we propose green silver nanoparticles, which we can synthesize through green roots using plants and microorganisms. These nanoparticles are highly effective against both gram-positive and gram-negative bacteria at both plankotic and biofilm stage. They can damage the bacteria by many different mechanisms by generating oxidative stress, interfere with the proteins and DNA, disrupt bacterial metabolism, which leave very little chance for any microorganism or bacteria to develop the resistance mechanism. On top of that, these green nanoparticles comes from green root, which acquire a green capping layer on their surface, which give them long-term stability and often enhance their antimicrobial activity compared to any chemically or physically produced nanoparticles. We also propose MOFs, which is called metallic organic framework together with green silver nanoparticles. In particular, we explore MIL or UIO66 because they are physically capable of damaging physically both bacteria membrane through stretching, impaling, and also mechanical injury. So for the ODIN project, the idea is to combine these two systems into one hybrid antimicrobial platform where the MOF can disrupt the bacterial membrane and the biofilm structure physically, while the silver nanoparticles simultaneously can generate oxidative stress and interfere with the bacterial metabolism and biofilm formation. The system we will develop here is we will mainly target to apply for chronic wound infection catheter and implant associated biofilms and hospital acquired infection where resistant bacteria are a major clinical challenge. As a team, I will be the main applicant and my expertise is mainly in green nanoparticles formation, AMR associated microbiofilm, and in vitro antimicrobial models. As a co-applicant, we have Professor Xinsao Sao from SLU Sweden, who is expert in MOF-based designing, material characterization, and also their antimicrobial applications. We also have Professor Sini from DTU Health, who is expert in immunology and in vivo animal models. As an industrial and hospital partner, we have Professor Roger Carlson from Sagarka University Hospital and also the founder of the company Nanoxenes and a professor at University of Gothenburg who brings expertise in infection, AMR, and healthcare associated infections. As a resources, we will be doing this project at D2 Healthcare and D2 Bright, where we have facility for the nanoparticle synthesis and characterization, microbiology labs and biofilm analysis, and in vivo models at D2 Health animal models and all. For MOFs, we have Professor Hinshaw lab at SLU Sweden, where we will do this MOF designing and characterization. And the expertise we seek is mainly the industrial or translational collaboration where we can have the expertise related with medical device or healthcare related applications. Thank you very much for your attention. I will be very happy to discuss this project further.